Okay, third time's a charm. This keeps shutting down on me, so hopefully it works. Okay, review guide for work and energy. First one is units, the different units we've used. For both work and energy, we are using joules. So that includes potential energy, kinetic energy, and total mechanical energy. For mass, we used kilograms. Delta X is displacement, and so it's a distance, and we used meters. V is velocity, meters per second. And F is force, and that was another new one, newtons. Fill in. A lot of this is from our notes. Energy is the ability to do work. If an object is at rest, then the amount of work being done is 0. Also, if an object does not move, displacement is 0, then the work is also equal to 0. So it needs to move in order for there to be work done. The law of conservation of energy states that energy cannot be created or destroyed. It can just be transferred or changed form. Frictional forces cause objects to lose their energy to their surroundings. And usually that's in the form of heat, just like our rolling ball lap. That's why our potential energy at the top was higher than our kinetic energy at the bottom. As the ball rolled down, some of that energy turned to heat due to friction. Total mechanical energy is the sum of the potential and the kinetic energy. Kinetic energy is the energy of motion. Object has to be moving for it to have kinetic energy. Potential energy is stored energy, so not moving, and it's based upon an object's position, usually how high it is above something. If you look at your formulas up here, potential energy is mass times gravity times height. So if you increase the mass, my potential energy will increase. Also, if you increase the height of the ball, my potential energy will increase. In the kinetic energy formula right here, it's 1/2 mv squared, mass times velocity squared. So if you increase the velocity or speed, the kinetic energy will increase. Okay, lots of problems in this unit. The cart shown below is a 0.5 kilogram metal cart. Blocks placed in the cart have a mass of 1 kilogram each. Be sure to add the total weight of the car with the weight in the car. How much gravitational potential energy does the cart below have at the top of the 30-meter high ramp? So we've got to figure out the mass of the car first. So we are going to do our mass. We have our cart is 0.5 kilograms, and we've got, looks like 2 blocks in there. So we've got 1 plus 1. So our total mass is 2.5 kilograms. Now to find our potential energy, which our formula is mass times gravity times height. So we have a mass, we already figured out, is 2.5 kilograms times gravity, which is always 9.8 meters per second squared, times our height, which in this one is 30 meters. Multiply all those together to get your gravitational potential energy, and you should get 735 joules. Next one, calculate the total mechanical energy. So we want both potential energy plus kinetic for total mechanical for a 6 kilogram object moving at 5 meters per second and positioned 4 meters above the ground. Okay, so we got to find both. We can start with potential energy, mgh. So for our potential energy, our mass is 6 kilograms. Gravity is 9.8. And our height is, what did it say? 4 meters. So you multiply all those together, and our potential energy equals 235.2 joules. Kinetic energy, 1/2 mv squared. So kinetic energy, we've got 0.5 times our mass, which we already said is 6 kilograms, times velocity squared, which is 5 meters per second squared, So 25 times half of 6 is 3. So our kinetic energy is 75 joules. Now, to get our total mechanical energy, we have to add those together. So 235.2 plus 75 gives you 310.2 joules. Okay, next, a 10 Newton force is applied to push a 1.3 kilogram block across a frictional surface that is 2 meters above the ground at constant speed of 0.25 meters per second for a displacement 5 meters to the right. So work. So we have to start with our work formula. Work, force times displacement. So we know our force is 10 newtons. So we've got 10 newtons times how far it went. It went 5 meters to the right. So our answer is 10 times 5, or 50 joules. Then, same scenario, wants to know kinetic energy. 1/2 mv squared. So we have 0.5 times our mass, 1.3 kilograms, times our velocity, which is 0.25 meters per second squared. Multiply all that out and you should get 0.04 joules. Make sure to square the 0.25. And then next, and it's a good idea for you guys to be doing these and plugging them into calculators to make sure you're getting the same answer I am. Don't just write them down. Make sure you can actually solve them. Next one, potential energy of a box as it sits on the edge of the table. So MGH, we already know our mass is 1.3 kilograms. Gravity is always 9.8. And our height is 2 meters. Multiplying all that together, and you get 25.5 joules. Okay, next here, we've got a picture to answer some questions. It talks about EG. Remember, that's energy due to gravity or potential energy. Sometimes you'll see EK, which is kinetic energy. Keep that in mind. If the ball at the top of the ramp has 1,000 joules of gravitational potential energy, how much kinetic does it have? Well, it's not moving. It's just sitting at the top. So none. At point A, we're going to say point A is about a quarter of the way down, not a half. A quarter. B would be about a half. So how much gravitational potential energy at A? So it started with 1,000 and went down a quarter, so we're probably at about 750. At point B, how much gravitational potential energy would the ball have? Halfway, half of 1,000. Yes, is 500. Sorry, my child is eating things. At point B, how much kinetic energy would the ball have? If it has 500 potential, total 1,000, it has to have 500 kinetic to equal 1,000. And then at point C, how much total energy? Total doesn't change at all. It's always going to have 1,000. So that's E. Okay, this one's got a lot going on. And this one, total mechanical energy that we put like this, is conserved and no energy is being transferred to the surroundings through the form of heat. Solve for the unknowns. So potential energy at 1. So we're going to start right here. We have a mass of 50 kilograms and a height of 4. So we're going to solve our potential energy at 1, mass. So we know our mass is 50 times 9.8 times 4. And when we multiply all that together, our potential energy there is 1,960 joules. Well, we know the ball is not moving. There's no kinetic energy, so it's 0. So our total mechanical energy of this whole system is 1,960. We know that's for both. And our velocity at the top, since it's not moving, is 0. So now we're going to look at 2 here. And our potential energy, our height is 3. So we're going to solve again, but our height is now 3. Same mgh. This is for 2. Our mass is still 50 times our 9.8 times our height of 3. Is that right? Yep. So we solve for our second potential energy here, and we get 1,470. Now, we know our total is 1960, and so to find our kinetic, it's going to be 1960 minus 1,470, which gives us 490 joules. So that's our kinetic. Remember, they have to add up together to get that. Now, we do have to solve for velocity here because it is moving. So this is where we get to use our crazy formula. 2 times kinetic energy divided by our mass. So we put everything in. We just said our kinetic energy is 490. Our mass is still 50. So you can do everything under the square root first, which gives you 19.6. And then you take the square root of that, and you get 4.42 meters per second. Okay. Next, what is the kinetic energy of a 150 kilogram object that is moving with a speed of 15 meters per second? Kinetic energy, 1/2 mv squared. So 0.5 times 150 kilograms times 15 squared, 16,875 joules. Remember to plug these in and try them on your own. This one, object has kinetic energy of 25 joules and a mass of 34. How fast? This is another velocity one. 2 times our kinetic energy divided by our mass. So if we put that in, 2 times 25 divided by 34 should give you, take the square root of it, meters per second. An object moving with a speed of 35 meters per second has a kinetic energy of 1,500 joules. What is the mass? Mass is 2 times kinetic energy divided by velocity squared. So 2 times 1,500, so 3,000, divided by our velocity 35 meters squared. So I'm going to do this out. 35 squared is 1,225. Divide those out. 2.45 kilograms. Find the gravitational potential energy of a light that has a mass of 13 kilograms and is 4.8 meters above the ground. Potential energy, mass, gravity, height. So mass is 13 kilograms, gravity is 9.8. Height is 4.8, just basic multiplying, but make sure that you know what you're doing on your calculators. An apple in a tree has a gravitational potential energy of 175 joules and a mass of 0.36. How high, so we're looking for a height, is this apple above the ground? Okay, and you should have all these formulas on that sheet in your notebook. 175 joules divided by mass, which is 0.36 times gravity, 49.6 meters. Height. Marble's on a table, 2.4 meters above the ground. What is the mass of the marble if it has a gravitational potential energy of 568 joules? So potential energy, gravity times height. We know potential energy is 568 joules. 9.8 times our height, 2.4. 24.1 kilograms. Okay, make sure you're really checking all this math on here. Good luck.